So now we are moving further. So in previous session, we have drawn this ray diagram for 6 number of speeds, and we have taken this structure equation 2132, and this ray diagram was drawn based on minimum shaft diameter criteria. Means our requirement is to minimize shaft diameter. So for minimum shaft diameter, we always need to consider ray diagram which gives us minimum RPM on shaft as a maximum compared to other ray diagrams, right? So we try to move the lowest node point. These are called as the node points, right? So lowest node point we try to move up. So in criteria A, if we recall, in criteria A, this node was the at the highest position. So that's why we prefer this, and due to this now we get reduction in the shaft diameter. So this is criteria A, means criteria where we consider minimum shaft diameter. And same diagram was given to all of you. For same structured equation, you are asked to draw ray diagram for less radial dimension gearbox, and you are asked to send me your response. So I just shared one response which I received from Pratik. I hope screen is visible and you can see this shared image. So here our criteria is to minimize, let me, so here you can see uh, our criteria is to minimize radial dimension. Now we are not more interested about reduction in the diameter of shaft, right? So when we get maximum reduction in the radial dimension, where we split or where we consider this node point at a mid of maximum speed and minimum speed, right? So at that time we get maximum reduction in the radial dimension. Otherwise, if you shift this point down, then increase in speed is with progression 5 raised to 3 and reduction in speed with progression 5 raised to 1. So again, that increase in speed that required more radial dimension. So this is the midway where we get maximum reduction. Whenever we position our node such that the increase in speed and reduction in speed with same geometric progression power, right? At that time we get maximum reduction. So for stage 3, this is fine. So we have considered N1, we got from N3, N3 one another line because we get 3 speeds by a particular gear cluster and 2 is the characteristic number. So after N1, next we get N3 from same gear cluster, and after N3 next we get N5 from the same gear cluster with progression 5 is to 2. So this is what the we can say one ray of one gear cluster. Now Pratit has shown 3 more possibility in stage 2. Now if you see this top one, this possibility that will shift this node point at the maximum position compared to this and this. So if you follow these 2 rays, then we get maximum reduction in the shaft diameter. But the radial dimension of gearbox would be more compared to this possibility and this second possibility, right? Similarly now, if you go for this last one, which is indicated by gray color, then this will give maximum reduction in the radial dimension because node is shifted down more. So maximum reduction in the radial dimension, but at the same time, diameter of shaft of this shaft one would be large compared to this node and this top node, right? So this is the one extreme position and this is the second extreme position. So for better or the midway of these two, we can go for this node, right? So this can give the optimum result. We can say we get less radial dimension compared to this top one, and we get less diameter of shaft one compared to this bottom node. So I prefer this middle one. So we get optimum result for both. We get reduction in diameter as well as we get reduction in the radial dimension. But as we discussed in previous session, if you are more concerned about reduction in the diameter of shaft, and if that calculated shaft is exactly matched with the standard size of shaft available in the market, then we can go for this as well. Then we can go for this as well, right? So we get reduction in the radial dimension, maximum reduction in the radial dimension, as well as we get standard diameter of shaft from the market. So we prefer this. But if nothing is available, means diameter calculated based on this node is not standard shaft diameter, then I would prefer this middle one, right? So this is what a good job done by Pratik. So he has mentioned here, if you want maximum reduction in the radial dimension, then you need to prefer this bottom one. So as per criteria 2, this we can say best. Okay. So this is the result from Pratik. Now we move further. Now same thing we'll do for 12 number of speed gearbox with criteria A, means maximum reduction in shaft diameter, because as I told you, that is in general accepted. So now, okay, let before moving ahead, let me discuss one method which is in general very simple method. Straight away also we can say which diagram is based, but there is one method which is called as a node method or node theory, based on which you can select again based ray diagram as per criteria 1, minimum shaft diameter. What you need to do, simply you need to give node number on a particular shaft from maximum speed to minimum speed. So for example, if you look here, if I talk about shaft 3, then as per node method, just give numbers, number 1, number 2, number 3, 4, 5 and 6, right? Similarly now, on shaft 2, maximum speed is N6 and minimum speed is N5. So only 2 nodes. And similarly now on shaft 1, 1 node. So just do total of nodes on each shaft. Then total of nodes is equals to 1 plus maximum node number for shaft 2 is 3. Sorry, 2 plus maximum node number on shaft 3 is 6. So total node number is 6 plus 3, 9. Right? Now let me again share ray diagram provided by Pratik. And let us give node number to this diagram. If we follow this gray color line, then give the node numbers. First of all, we are starting with third shaft. So let me write. Suppose here, this is 1, this is 2, 3. Always on shaft, last shaft, you get 6 number of nodes, right? 1, 2, I think this is 3, then this is 4, and 2 is 5, and this is 6. So always we get on last shaft, number of nodes are equals to number of speeds which we get from ray diagram. So that is in general. Now if I follow this gray color line, then what is the node number? So again the maximum speed is n6, right? So I give here again 1, sorry, 1, 2, 3, and I stop at the minimum speed available on that shaft 2. So 4. Again now here on shaft 1, 2 and 3. Okay, so if I do total, obviously I'll get node number more. So here 6 plus 4 plus 3, right? So we get 13 as a node number. So more node number, worst is the diagram as per the minimum shaft diameter criteria. Okay, so this is one theory, basic theory of node number. So that also you can apply quickly on your ray diagrams to select best ray diagram. Okay, now we are starting ray diagram as per minimum shaft diameter criteria for 12 number of speeds. I hope paper is properly visible. So now ray diagram for 12 speeds, and I am selecting a based ray diagram, based structural equation as per the different criterias which we have discussed. So I would say this is the universally accepted structure equation which fulfills all the requirements which we have discussed so far. So I use only that structure equation, base structure equation. This is base structure equation for 12 number of speed. Right? Okay. Now for this equation, let me draw first of all structure diagram. So to draw structure diagram, we need to first of all draw vertical lines. So how many vertical lines we need to draw? I would like to know from participants. Can anybody unmute himself and respond? How many vertical lines we need to draw for structure diagram? Yeah. So we need to go for 4 vertical lines. The reason is because this gearbox is to be designed in 3 stages, right? So we go for 4 vertical lines where first line is indicating input shaft, second, third and fourth, right? Let me extend it further because we need to draw horizontal lines as well. Now how many horizontal lines? How many horizontal lines we need to draw? Yeah, we need to go for 12 horizontal lines because this gearbox is for 12 number of speeds. So let us draw 12 horizontal lines. So line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right? Now let me give RPM number. So N1 list RPM 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right? Okay. Now let me draw. First of all, what I need to do, I need to pick midpoint, right? So I pick midpoint of N1 to N12. So that I get between N6 and N7, right? So on shaft 1, let me give shaft number. This is 1, 2, 3 and 4, right? Now, 2 speeds and 1 characteristic. So 2 speeds, so 2 lines with line spacing 1, right? So these are the 2 lines. Now, three lines in stage 2, three speeds, so three lines with line spacing in successive between successive lines is 2, right? So by default, first of all, I need to draw one line straight away. So from this to this, and then after 5 raised to 2 power. So characteristic number is 2. So one line is here. And second line is here. Similarly, from this ray, one line is straight away straight. Reduction with respect to these two. Increase in speed with respect to this middle one is 2. So stage 2 is over. Now stage 3, two lines with line spacing 6. So if you consider this one, first one, then the bottom most speed in stage 2, then from that just connect with the n1, then we get 5 is to 3 here, and the next is again 5 is to 3 on the top side, so n4 to n7, right? So from remaining 5 nodes I need to do same from this node to n2 and from same node n8. Then again overall progression is 5 is to 6. Similarly now from this n3, from this n4, from this n5, from this n6. Similarly now from this n9, n10, n11, n12. So this is, we can say, structure diagram, right? Now let us draw ray diagram for this given structure diagram. Again, how many vertical lines we need to go for ray diagram? If the condition is Nm is not equals to N12 maximum RPM, motor speed is not equals to N12, then I need to go for first of all, how many vertical lines? One more than the structure diagram, so 4 vertical lines. Now I need to go for 5 vertical lines in ray diagram to indicate shaft, motor shaft as well. So now we draw vertical lines, total 5 vertical lines, 1, 2, 3, 4 and 5, right? Now how many horizontal lines? Due to this condition I need to draw one additional horizontal line which indicates speed of motor, right? So this is n1, n2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the last line to indicate nm, right? So now I mentioned speeds on last shaft n1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and finally nm, right? Done? Okay. Now I need to start with last stage. So in last stage, now important thing is which criteria we are applying. So we are applying minimum shaft diameter criteria, right? So based on this criteria, always we need to arrange such that node on the input shaft of particular stage should remain on the high speed, right? So I pick N1 first of all. So from N1, if I go up to N5, then how much reduction in speed? Again 5 is to 4 reduction, which is the limiting condition. I consider line from N1 to N5, right? Now, after drawing this, next is we need to maintain same group characteristic number. So group characteristic number for last stage is 6. So this is the N1, which is the minimum RPM available. Then maximum RPM should be with progression 6, which is given on this, which is N7. Okay, so N7 is here. So I need to connect N7 with N5, right? So we have drawn one ray. Now we are moving in backward direction. So we are moving in this direction. Now we'll complete remaining node later. Now we are moving to previous stage, which is stage 3. This is stage 1, sorry, stage 2. Then stage 2. Again, we want to follow minimum shaft diameter. So again, if from N5, if I go for 1, 2, 3, 4, reduction up to 4, then I need to pick N9 speed as the input speed, right? So I consider N9 input speed to achieve N5, right? So first line is here. After drawing this, again, I need to check what is the characteristic number of stage 2, that is 2. So the next speed is N7, which is given here. See, from this, now next speed is N7, N5 to N7. Then I maintain 5 is to 2 power. So let us draw that. I connect N7. Let me give the shaft number again. So this is motor shaft M. This is 1, 2, 3, and 4. Right? So on shaft 2, N7, on shaft 3 N7, to achieve N7 we need to again connect with N9. So 5 is to 1. Now again the next third RPM is with same progression 5 is to 2, that is N9. So N9 I connect here. So I got 3 speeds in stage 2, right? Again, now after this this is the input shaft. So input shaft, I, I need to draw 2 lines with progression of 5 is to 1. So let me first of all, we are talking about minimum shaft diameter. So we need to connect this node with the maximum possible node such that reduction from this should not go beyond 5 is to 4, right? So with that, I'm connecting N9 directly with the maximum speed available from gearbox, which is N12. Then, and again, I need to maintain characteristic number of particular stage, which is 5 is to 1. So next RPM is N10. So I connect these two, right? And after getting this, finally, let us connect shaft, this input shaft with the motor shaft to build drive, to build drive, right? So here we get build drive. Okay. Okay, so we have drawn a one ray. Now we are moving backward. So it is very easy to do that because we already have one ray. So quickly I'll show you. See, From this, I'll draw one green. It is similar to this. It's a copy of this three ways. So one straight away. Next is after progression of 5 is to 2. So this pink one will be on N8, and last this brown one will again with the progression 5 is to 2 because characteristic number is 2. So from this I'll connect this with the N8, sorry, N6. Then okay, from this all, now again I need to do mirror of or the copy of this, but the progression I need to just shift all these two lines by one line up, because here this node they are having progression of 5 is to 1. So quickly I'll show you. This will be on N2, this will be on N3, this will be on N4, this will be on N5, this will be on N6. Okay. Similarly now, from each node, already we have drawn this one line up. So again, from this node N8, from this node N9, from this N10, N11, and finally N12. So this is, we can say, ray diagram based on this structure diagram, right? So this is our final ray diagram. For this, we have drawn this ray diagram based on minimum shaft diameter. But if you talk about minimum radial dimension, then what we need to do? We need to pick this node, N4 node. We need to pick this N4 node. Then 3, 3. So it will, okay. Yeah, one another twist now. See, I cannot go for N4. Here we have only one possibility. The reason is, if I connect this N1 with N4, then see what happened. This red ray will connect, let me indicate, that will be connected with N7. From this, if I consider N4 as the input speed and as the output if I am getting N7, then how much is the uh, progression, geometric progression in increasing order? It's a 5 is to 3, which is violating 5 is to 2 condition, right? So we have only one option here. We can only go for N4, minimum shaft diameter. We cannot go for radial dimension, minimum radial dimension. If you go for that radial dimension, then you will violate this this rule, means a pitch line velocity rule. I hope it is clear, right? So we have only one choice here, but yes, if you move further, then you may get some possibility from here. See now, if I don't have flexibility to select N4 due to violation of this condition, but I have flexibility here, for example, because from this I can connect at this point, then 5 is to 2 and 5 is to 2. So I can connect these two nodes. Let me show you by dotted line. We don't have any flexibility to change here, but I can change. Let me use different color so that will give you proper fill. I have choice here. I can go for line like this to this, and again from this line to now maximum increase. How much is the increase? Increases, if I connect like this, then I get one line here, this pink line here, and this green line here. So I can go for minimum radial dimension for stage 2, but it is not possible in stage 3, not possible due to this condition. But for stage 2 it is possible, for stage 1 again it is possible, right? So I hope it is clear. Now If you have any